Good morning. Wow. I was trying to be energetic, but yeah. Happy to see so many people this early in the morning. I think there were a couple beer too much last night, especially like the port with gin or tonic thingy, which I've discovered very late in the evening. Recently, I'm a consultant, and recently I was hired by a client, and at some point he asked me, and he said, like, Dennis, you know what, we have this something running in production, we don't know exactly what it is. It's a .NET process, and you seem to know a lot about .NET and C#. Would you mind taking a look at it, because it seems to be crashing all the time. We get remarks from some kind of external supplier. I thought, yeah, sure, of course, I love legacy code, I'm addicted to it, so I need my daily dose. So, and this is a true story. I started to check out, like, what was it? Like, where is it? So I needed to get access to a machine in production, which is typically very difficult because you have to go through an infrastructure department, which are very protective of their production environments. And there was a process running. It was actually not a service. It was a Windows Forms application running in desktop mode, and all the logging statements were printed in like a big text box. There was no log file, nothing. Okay, cool. I mean, I've seen my share of things, 27 years of experience. So I was trying to look, okay, let's look at the code base. So where's the code? Everybody looked at me like, I mean, you're the consultant, you know, you're the specialist. You know, where's the, I don't know. Where do you keep your code? This is, I'm not joking, guys, this is really true. So they said, like, it's probably in Azure DevOps. Okay, cool, wasn't in Azure DevOps. Then where is it? Oh, it could actually be on a network drive. I said, seriously? So I went to the network drive. Well, it took a couple of days to figure out in which directory I should be looking for, because nobody was mounting that network drive anymore. Turns out there was a folder which had 5 copies of the same source files, you know, plus 2 of them called backup.zip, .2, you know, between brackets, .zip. Yeah, and then I have to figure out, like, okay, how am I going to do that? What version of the code base is there? So this is the kind of stuff that I run into. I hope you haven't run into that. I'm afraid you did, actually, because, yeah, this is the reality of our software development. The fact that you're all here means that you all have to deal with brownfield scenario. We all love greenfield stuff, but, yeah, I happen to do that. So I'm going to share in the remainder of this session my tools, practices, and principles, basically the way I approach these kind of problems. And I hope it's interesting enough for you. I try to keep it interactive. I like that. So that's me doing a lot of stuff for 26 years, turned 50 recently. I don't know why I keep repeating that. Apparently it's a thing for me. And I basically help clients or companies, you know, improve the entire software development lifecycle. From ID to production, I challenge everything. That's really annoying sometimes. You know, like, why do you have your source code in a network drive or network, like, I don't know. But yeah, so I change everything. I challenge everything. Yeah, I'm the annoying person that you pay for. I have a blog, I have coding guidelines for 20 years, some open source project. Any .NET developers here, just checking? Oh, with the rest, architects, managers, product owners, architects, I assume. Yeah, and I have a little library which is reasonably popular in the .NET space. Who cares? If you create a nice picture or, you know, put something on social media about my talk, can be nasty, can be public. You can actually win a 1-year license for JetBrains Rider. These are my handles, if you care. Oh, and I'm an MVP, which means nothing other than I get free licenses from Microsoft. So, how does this work? Well, I try to somehow, picture the way my brain works. And my brain is very, let's say, chaotic. Although I'm a pretty structured person, but it's really like a creative process. But I try to create a picture. So what happens typically is I try to understand the production environment. That's what it starts with. And we're going to cover every little, circle. I'm going to cover this in a separate set of slides, so don't worry. But it's on the high level. I understand the production environment. What's running there? Where is it running? What is the actual production environment? Is this the production environment? Is this maybe an acceptance environment? Or a development environment? Is there another environment that is also being used that nobody knows about? That's useful information. Then understand the code base, which is a challenge because writing code is hard. Understanding other people's code is even harder, right? Understanding my code, it's impossible. Then I find that code. I love deleting that code. The best day at my job is the day where I can actually delete code. I don't know, is that weird? You know, anybody shares that feeling? Yeah? Cool, see? Yes. When you're young and you're just graduating, you love to create code. I just delete it. Awesome. And I can send an invoice to my clients and say, I deleted code for you. Here's an invoice. Yeah. Okay. Then I build a safety net because I don't like to touch existing code without some kind of feeling that I didn't break anything. I want to remain confident that everything still works as it did before, or didn't work as it did before. Then I start to improve deployability because I don't actually want to copy files from a network drive onto a server, then fiddle around by hand. Doesn't make sense. It's 2023, it's almost 2024. And then, of course, I'm going to improve the quality and maybe even improve the design because code is easy, design is more complicated. What's next? Improve the architecture. Sure, simple as that. And of course, this is not a waterfall approach, just like I told yesterday, I said that about TDD. I go through these cycles a couple of times. And you should be doing that because you keep maintaining your code base. If it's production code, if you're being successful with that code, then you use this stuff. So let's start with the production environment. I'll put the slides online, so if you don't need to make pictures. I know you want to win the license, of course, yeah. So this is literally what I did. Getting a remote desktop session to that environment, if it's Windows, or an SSH session if it's Linux, get all the executables, DLLs, log files. Literally, it means I have to send a request to the infra department through top desk or some kind of issue tracking. Can you get me all the production environment files? And then they come back like, what do you need? Yeah, exit DLLs, and then what they give you back, exit and DLLs. Now, but I also need log files. There's no log files there. There must be log files. Can you just give me remote desktop session? Yeah, it's not in the same folder. It's actually on a different drive. But guys, you're infra. You know your environment. You know if there's folders in there that you don't recognize, then I want those. I want to have them. Configuration files, of course, they say, yeah, but that's production data. There's passwords in there. I don't care. I need to solve that problem. I need everything you have. Okay, that's the first step. Then, that's interesting, I'm going to compare the binaries, in this case in .NET, with source control, given that you actually found source control. How do I do that? I don't know, go to the repository, which is one way of doing it. I'm also, I've used this a lot recently, .peek, or one of the tools that you can use to decompile C#.NET code. I'm literally then comparing the code with the one that's on my network drive. You remember that I told you earlier? To see, especially, and that's what I'm looking for, is are things commented out? Is there code that's commented out? And I want to know, was it also commented out in production, or it's actually there? Which is scary, because you'll find stuff that, wow, my God, what did this person do? Did he actually learn to program? Well, he must have, because it's in production. But now what? What if you have actually 5 different versions of the source code? Well, it's a nice trick I learned from a colleague, which is completely obvious if I tell you, is to put one folder in source control, commit, then copy the contents of the other folder in it and see if there's any difference. Yeah, it's actually pretty neat. Why not? The scary part is if you eventually discover, well, you're first happy because you discover that 4 copies of the same source folder were the same, there were no changes. But then there was the 5th, and suddenly you find all kinds of new changes, but that apparently never reached production. Well, that's a day in the life of a consultant. But it's a nice trick. Then, of course, you start to look at log files and crash reports. Like, did it crash? What kind of logging? And then you see like warnings all over the place, errors all over the place. And everybody's saying it's working. It has been working really well because developers seem to be doing a bad job. Crash reports, like is there anything in there, like stack traces that I can use to understand what's going on? Anything that gives me a good feeling like what's actually happening in production, because that's what I need to be able to improve it. Then, and that's the most difficult part, I take those binaries, I take those production values, and try to get the thing running on my local machine, which can be quite hard. And this feeling, yeah, it's really true. This is an AI-generated picture, so it doesn't look like me. But that's what if you actually get it to run, and what's even better, to be able to reproduce that particular issue they reported. That's really cool. In my case, it was very easy. Whatever message I sent to that process, it just crashed immediately. So that's great. Then, understanding the code. Okay, I usually start looking at the project dependencies. Look at the folder names. What are the names? Is it using some kind of functional separation? Is it using technical folder names? Is it using some undefined pattern There's no convention at all because we're just doing whatever we feel like that day. Also look at namespaces, identifying, is there generic code, is there specific code, are there dependencies that I can identify? Anything, and you know how that is. You look at code, you immediately start to build some kind of mental map of how everything fits together, right? If you're lucky. Most cases you don't, of course. But yeah, here's a nice example. Also, this, for example, what Rider does, has a built-in project viewer, can also be helpful to understand like the thickness in this particular picture, and this is from my own open source library, shows you also the dependency, and like how strong is the dependency between different projects. Again, it's all to feed that mental model that you need to understand the code base. Maybe you use something like a type dependency diagram that you have in ReSharp or if you use Visual Studio. Unfortunately, Rider doesn't have it. Can also be very useful, although this is not very easy to read, of course, but it can be useful to understand and dive into. Ndepend is very powerful. Unfortunately, it's not free, but I tried it a couple of times. It can do a lot of stuff that other tools can't do. But it's also totally fine, and this is what I do a lot, is create your own diagrams. If you went to, I think there was a session by the author of C4, the C4 model, which is a very lightweight way of representing like what your system looks like, how it interacts with the rest of the world, and one level deeper, what are the different components. I usually do that as well. I create that in Draw.io on Confluence, which really helps me create that mental picture, but also explain it to other people, because this is quite lightweight, and you can use it also. You can keep it and use that for the future. Or, I don't know, you can even do class diagrams. I'm going to repeat my joke, but this is UML. This is something that we used to do in the past when we were very young. Still useful. Of course, you can also use your IDE. You can actually, find all the inheritors of a particular class, method, see where it's overridden. Maybe see how many levels of inheritance you have. That was very popular in the past, inheritance, object-oriented programmer. And people love to create multiple classes that all inherit from each other. So to make it very easy to reuse things and make it very complicated to understand what's going on. Maybe, and this is a Rider feature I really love, it's called show value origin. So if you look at a parameter value, or even a variable inside a method, it can actually show you exactly where this value came from. Even if there's multiple calls from different parts of your code base, you can see where did this config setting come from? Because it's magically appearing in my code base, I have no clue. Where did it come from? Of course, with legacy code bases, everything is static, it's very easy to find. But more complicated with dependency injection, this is a very useful feature. This is what it looks like if you use that kind of thing. Use the tools. More examples. Or, and this is pretty cool, because now we have things which are way smarter than me, or you, I don't know, AI. I use that a lot. So in this case, I'm using Rider, and I have a preview license for their AI assistant, which is ridiculously smart. And I can just ask him, explain the code. And then you get this whole block of text. But what I love is, in summary, the aim of this method is to return an array of field info objects representing non-private, non-protected fields of a given type that match a given visible criterion. Okay, that's quite obvious for you. But I use this for that particular example because the original author of that .NET process that was running on this machine that I started this to talk with actually copied code from Code Project. That's a very old, archaic system where you can publish your information. That was doing RSI encryption by hand. So they actually copied that code. And I suck at this. Oh, sorry. I am not very good at this. I literally asked my AI to explain that code. And then it said, this remarkably, it looks very close to, what was it, AES 256 with padding something, but it's slightly different. It explained that to me. But that's incredible. I can do stuff that I never could do in the past. I now know a little bit more about encryption and decryption algorithms just by using a tool. Use those tools. They're very useful. Same with ChatGPT and others. AI Assistant, which is a plugin for all the JetBrains products. They're building their own tool. I don't have any stocks in JetBrains or something, but these guys are just doing their. I do have stickers. No, but it's pretty powerful. Doing the same thing here. I use it everywhere. I even here, the question, I don't even read that. I say, how does it handle explicitly implemented properties? I'm literally asking a question that I would ask myself, and it actually figures it out. That's just marvelous. This is the world we live in. And it's not a threat. It's something that empowers you, makes you even better, which we all want. Of course, you collect so much information, you need to track that. I mean, we're still software developers, and we hate writing documentation. But for me, it's important, because my brain goes all the left and right. In fact, I probably forget what I did yesterday, so I need to write down everything. All my notes, links to relevant pages, maybe pieces of chunks of code that I copy-pasted to explain it to myself. Track everything together. That's how I do it. By the way, it also helps the truck factor. So if I get sick, you know, I'll stay in Portugal because the weather is so great, and I never come back home, then at least you have the notes that your colleague can continue with. So that's important. So finding and removing dead code. Well, that's quite easy. Who, and I want honest answers here, because you're all professionals. Who actually makes all that code public by default? Good. Who's very, very, let's say, professional and makes everything internal by default? If you're a C# developer, for example. Okay, one person. You can stay. The rest needs to leave. So every language has this concept of visibility or scope. Unfortunately, in Microsoft world, if you program in C#, everything is public. The thing is, if something is public, it's very difficult for your IDE to make assumptions about the usage of that thing. If you make everything internal by default, it may actually, and you have a good IDE, it will actually tell you, like, hey, you made this method is not used anywhere in this code base. And since you made it internal or private, the IDE can make assumptions and say, yeah, but since it's private, you can just throw it away. And as I said earlier, and I saw some happy faces when I mentioned that, throwing away code is the best thing you can do. So that's a simple trick. Make everything internal and see what breaks. And if nothing breaks, your IDE will probably make everything gray, and you can just delete it. And this applies also to parameters, to everything. You can already see, like this one, include private is false. It's grayed out, which means it's completely unnecessary. You can just delete it. I love deleting code. This as well, commented out code in source control. Why are we still doing that? That wasn't a thing 20 years ago, and it's still not a thing. We have source control for that. And most IDEs these days will complain about that. I mean, I can imagine you feel like, oh, but this is an open door. Still, everywhere I go, I find this. So, deleting code. And deleting code is safe, right? Because you're pretty sure, unless maybe somebody's using a reflection, which we never do, because it's completely safe. But the next thing is to build a safety net. We want to have something to retain that confidence. Well, add code coverage. That's one step. Yeah, but what if you don't have unit tests? Yeah, then you have a problem anyway. If there are some kind of automated testing there, then code coverage is a nice tool to give you an indication of where is the coverage, where are the black spots in there. Because code coverage, by the way, should not be misused. It's not a management tool or anything like that, although managers love to use code coverage and put it on a dashboard somewhere, like you shall have 90% coverage, otherwise you're not, I want to say the word again, I think I can say suck. Anyway, it's a good part. Coverlet is, of course, in the .NET space very popular. Coveralls is a free open source project that you can use to publish it. I'm using it in my own open source project, Fluent Assertions. Very useful. The other thing is, and I don't have, anybody read the book by Michael Feathers, Working Effectively with Legacy Code? 1, 2 people. It's brilliant. It's very old, and the guy made a fortune out of it because he lives on Miami Beach, at least I assume. And one of the things that he talks about is that you should actually, if you have no test at all, is introduce some kind of set of tests that really are completely unmaintainable. It doesn't matter. The only thing those tests are doing is repeat the current behavior. So if you have no test at all, you just create a test, a unit test, automated test, or whatever language you have, that interacts with the application. Then you observe the response, and you put the response in the assertion. So if you run them, they will all be green, of course. But it also means if you start touching the code base, you have that safety net. And it doesn't matter that it doesn't follow all the principles of TDD, as I also explained yesterday, because they're throwaway tests. They're temporary safety nets. And if you draw that, like make that visual, it looks a bit like that. It may even include a production copy of the database. Doesn't matter. It is your safety net. And it's a very powerful technique that I've used many times before. Even with these, this RSA encryption thing, I literally wrote a test that would execute that RSA code to see if the public-private encryption worked correctly. Then I ripped out the old code, used the standard stuff that comes with .NET or some open source project that's properly maintained, and verified if I would get the same result. That is a characteristic test, a very small, focused one, but you can go all the way upstairs. Yeah, but then you have a database. It's going to be very slow, and they might be brittle, and you may not be able to run them in parallel. Who cares? You have a safety net. That's better than nothing. But then if you do have a database, you can still do something like test containers. You can actually, and I think I mentioned that yesterday as well, you can actually spin up a Linux container with SQL Server in it, have it restore a production backup, run those characteristics tests, and at the end throw it away. That's perfectly okay. You can even set a build pipeline for that, like this. Maybe in addition to these automated tests that interact directly with the application, you also want to add a couple of UI tests, maybe using Cypress or the Playwright or some of these tools. They may not be the ones that you want to keep for a long time, but again, it gives you feedback that you didn't break anything. And when you deal with legacy code, you all know that the most important thing is that you don't break anything and that you feel that you didn't break anything. Because the worst thing that can happen is that you get, you send that invoice, and at the end you put something in production, it didn't work, right? Okay, then the next step is, of course, because we now have the safety net, is to improve the whole deployability of that. Simple thing, add a build script, something that you can test locally, that compiles everything, that runs the characteristics test, maybe restore a production database, set up that test container, do whatever other ugly things that are needed in production to get the application to run. It's just so that you can repeat it continuously, because you don't want to have any manual steps in there. I'm very fond of Nuke. Not the best term, best name for a project, but it's an open source library in the .NET space that actually allows you to write your build script in C#. As a C# developer, I acknowledge the fact that the build script is actually something that evolves with your code base. And I guess you get that because, yeah, you start simple with all the ugly stuff, then you start to refine that. I want to be able to run it. I want to be able to debug a build script. I want to refactor. I want to be able to evolve and put it in source control. Which also gives you like nice overviews. You can just render a representation of all the steps in your build process. It's just a tiny tool, but it makes a world of difference. If you are using Azure DevOps, stay away from YAML. That's the worst tool that Microsoft ever invented. Well, they didn't invent YAML, but they did decide to use it. It really makes your life difficult. It's much easier to use something like this, or something equivalent in a different language. A versioning strategy, yeah, that's another thing. If I go into an existing repo, I look at the branch names and at the names of the tags. And quite often, that gives me a pretty quick indication of what kind of version strategy it is there. Anybody knows about Git flow? Heard about Git flow, GitHub flow, OneFlow, stuff like that? If you just have a main or master branch plus a develop branch and maybe a release branch, that already gives you an indication what's going on. What I find very frustrating if I find a repo with tons of feature branches from all kinds of people, and it's completely unclear what is the one that is supposed to represent what's in production. That should be obvious. And what is the next one? And why do you have all these fixed branches, even though tags are already beyond that point? Like the last tag is 1.12, and you still have fixed branches called fix 1.2.6. Why? Is there a reason for that? Is there something significant that I missed? Did you do some kind of backporting or released a patch on an earlier version? That needs to be clear. And quite often, or almost never, it's clear. This is Git flow. I think this is GitHub flow. And I think this one is OneFlow, which is pretty new. I don't like this one, by the way, but it's just for completeness. And by the way, and then you can do automated version. Because if you have a certain, let's say, ad hoc convention for your branching strategy like Git flow, then you can use tools to generate versions. Again, you make that part of your build pipeline. Like Git version is a very nice tool that will take the name of the branch, look at all the tags which are there, and based on that, make assumptions about what the version number is going to be. It knows that if your branch is called develop, that is going to be the next version of your product. And it will call them alpha.1.2, also take into account the number of commits since the last tag. It's pretty smart about that. Sometimes a bit too smart, but it's very easy. You don't have to deal with the whole versioning anymore. And if you're in a .NET space, it will automatically calculate correct NuGet numbers. It produces a number that includes even the hash number of the commit that you can put in your assembly, your executable, and everything. Because that makes it easy as well. If you have an executable in production or DLL, you can look at the properties and see that what is the exact version. Even better, if the hash of the commit is there, there's no doubt about what the version is now. So you should do that. Here it is what it looks like. There's a lot of information here. You don't need to be able to read that all the way in the back. What else? Yeah, this is what it looks like in this nuke build script. It's just a little bit of C# that you invoke, but it's properly integrated. Makes it very easy to work with. Then logging. I already mentioned that people do not always think about logging. So let me ask you a question. Who actually has logging guidelines in their project? Ooh, not a lot. Because I assume that some of you are developers, the rest are architects. And architects love guidelines, right? No? Okay. So it is important to understand what a warning means. It is important to make very clear to developers when you should use information level logging. It should even be more important to define what does error mean or fatal. What's the difference for that? How do you deal with that? You know, and also because the log files are typically not just for you as a developer, they're also for the people that are monitoring the environment. They need to understand when they need to act on that. If you didn't define that, that's important. And it becomes even more complicated if you have like a distributed system, then messages flow from one system to the other. You need to think about, you know, causality and correlation IDs and stuff like that. You need to define that. And with a legacy code base, quite often this wasn't really a thought of, and it helps by introducing that rule and starting to adjust all the logging levels, so it makes sense. Because in production, there should not be warnings. And if there are warnings, there's signal. There's signal that something might be going wrong soon. If it occasionally happens, then probably it's a normal situation. Maybe you haven't handled your exponential backup logic, or you were not using some kind of retry policy correctly. But it shouldn't happen that often. A file full with warnings and exceptions and stack traces, that's a bad signal. And the same with exception strategies. You know, all these try catches all over the code base with a log statement, swallowing exceptions. Well, that was the problem that the original case that I started this talk with. Somebody was using try catches all over the place and basically swallowing everything that happened. So the application was still running, but there was a background thread that crashed. The rest of the application did it new. Everything looked like, okay, I'm still happy, but no incoming messages were processed, you know, because somebody wasn't really thinking about that. Doing this kind of stuff, exception handling, doing it correctly is quite hard. And I'm pretty sure you all know that. So yeah, define that. Maybe adopting open telemetry. I think there were a couple of talks about this conference. Don't do this, by the way. Don't throw, this is C# specific, don't catch an exception and then throw X. You lose the stack trace. The next step is, of course, now we have this build pipeline, is to add some kind of deployment strategy behind that. Again, I love automation. I don't want to do things by hand. So in this case, for example, we use Ansible. And there's other tools for that, if you have your own infrastructure. If you're running stuff in the cloud, my go-to software now these days is Pulumi. It's brilliant. Anybody using Terraform? Throw it out of the window and switch to Pulumi, please. No. Anybody not doing RM templates, biceps maybe, stuff? No infrastructure as code? Manual deployments? Okay, cool. You're honest. Pulumi is an open source project that allows you to write all your deployment code in your preferred language, which could be Java, JavaScript, C# if you love that. And again, same advantage as with everything else you do in a programming language. Refactor friendly, you get proper IntelliSense, you can read it, you can understand that code if you look at it. I've had a lot of experience with Terraform. My problem was if I haven't looked at the Terraform definition for like a couple of weeks, I have no clue what it's doing because there's no documentation, there's no IntelliSense. I want to be able to, you know, scroll through the code, maybe even debug everything. And that's what Pulumi does. It's not an abstraction. It's more like a framework that allows you to work with Azure, AWS, and Google in a very nice, structured way. And again, deployment code is also code and needs to evolve with your code base. So yeah. So the next step is prove the code. Well, maybe a good start is treat all warnings in your code base as errors. It's a good start. And fix them. I mean, I think in the newer .NET versions, we even have 7 levels. Just put it at the highest level possible. Make sure everything becomes an error and fix those, because there might actually be hidden things behind that. In .NET, it's also very popular to suppress warnings. Yeah, suppressing issues is, of course, not the best thing. However, we don't want to be dogmatic. There are some things which you may not want to fix in the current state of the code base, and do that later and make that explicit by putting it in source control that you actually suppress something. But that's a good start. The other thing is using something like an editor config or ESLint if you're writing in Java or TypeScript, which works really well. Especially editor configs, not just for layout, but for example, if you use Rider, you can also set up all the formatting and the auto cleanup rules that it has, like you want to use, for example, the new operator, and then you can basically say, tell your IDE to reformat the entire project automatically based on those rules. That's a really good start. It will create a huge pull request or commit, but that's fine, that's just once, and then you're done with it, and you never have to deal with all the layout stuff. It will clean up the code, remove all the commented out code, it will make your life a lot easier. If you're in the .NET space, then these days we have Roslyn analyzers, and they're beautiful, because Roslyn analyzers can do a lot of stuff that the IDE and the language, the compiler, doesn't do. It can actually make sure that your XML comments are correctly formatted. Yeah, but I don't do any code commenting. Okay, that's fine. But if you use Link, I don't know if you were in the presentation by Daniel Marbach yesterday, it actually helps you use the right structures, the right API, because a lot of stuff in .NET that use Link can be perform pretty bad, and there's a lot of replacements for that to make it faster. The Russian analyzers actually tell you that. So you can just gradually enable them. You can even enable them on the visual folders because you're still refactoring the code base. And enabling that is something you put in the editor config, so it works in all your IDEs. Nested conditional statements, you know, the question mark and then the semicolon, you know, that a condition, and if the condition is true, it returns something, and otherwise it returns something else. Some people actually love to create nested structure. You know, question if something is true, then there's another condition, there's another condition. There's a Roslyn analyzer that tells you, don't do that, don't do that. Long methods, define long, okay, but it can check that. Single type per file, small things that will help you make that code base gradually better. Async, also, make sure that you await an async method, you know, for the .NET. Has anybody actually noticed that somebody was calling an async method in C# and not awaiting it? Scary, because you think it's doing something, but it's not doing anything. There's an analyzer for that. Nullable types, I think Maarten Balio had an entire session about this. You can actually, and that's .NET specific, C# specific, enable nullable types on file-by-file basis. And as soon as you do that, the compiler is going to interpret and make assumptions and try to understand, like, hey, you're passing a null value here. Is that what you intended? This cannot be null. Nil. You have to be very specific about that. And because you can enable this on file-by-file basis, it's also something you can gradually introduce in your code base. Like here, there's an example. And if you're really at the point that you want to enable it on the entire project, you can do it with this one. Or maybe just a newer version of .NET and bump the C# version. That makes a big difference. Yeah, but what if I'm actually still on .NET Framework and I cannot use new C# versions? Actually, there's a nice, oh yeah, by the way, these are the tools that you get, global uses, string interpolation, switch expressions, very beautiful. You can make your code a lot easier. Pattern matching, I use that a lot. Nothing to do with regular expressions, by the way. But if you don't have that, there's something that's called Polysharp, which is an open source library, which you can add to an existing .NET Framework library project, and it will generate on the fly a bunch of attributes that will suddenly light up all the new C# features. And that is awesome. So a lot of stuff is not available because the compiler actually, so if you install a new SDK of .NET, you get the capabilities, but it needs certain features in the framework. But it's not tightly coupled to the framework. It just needs to have certain attributes available, which have to be in a system namespace. You can even write them yourself. This works with the new init qualifier, but a lot of other things you can enable that. And just add that project and it will do it for you. I use that also in Fluent Assertion. Beautiful. See, there's an example of all the stuff here. Is external init, that's a new thing. Or module initializer is a way to execute some code at the first time your assembly is loaded. String syntax, which will enable regular expression highlighting, stuff like that. That's nice if you have to deal with legacy code. Because usually you have to stick with .NET. If you're, like in my case, that was .NET Framework 4.7, because it was still using SOAP, something from the past, and WS star, you know, the Death Star, stuff like that. I cannot move to a new .NET version, but at least I can use the new compiler syntax. Directory build props, maybe you know that one. Instead of copying all the dependencies and NuGet packages to every project, you just put it in this file, put it in the root of the directory, and every project will automatically inherit all the settings. Naming, improving, yeah, of course. Crappy name, that's a good name, right? I actually asked my AI assistant a couple of times, like, can you actually provide me with a better name? And it will look at the implementation of the code and use that to come up with better names. That's nice. Because naming is hard, right? It's one of the most complicated things next to caching, and there was one other. Oh no, that was the off by one error, yeah. Encapsulation, yeah, one of the principles of object-oriented programming. You can do that. Here's a nice example. I have a class or a thing order that has a property called order lines, and I'm verifying whether the order line contains an order which has a value that's higher than 10K. If that's the case, then the entire order is marked as high valued. This is weird, because basically there's code outside the order class or order type that makes assumptions or decisions about what's a high-valued order. A lot of people do that. Instead of that, you can just have an order class that actually does that for you, and even maybe an order lines class. This is encapsulation. That's the principle that we learned 20 years ago. I hope we're still learning that. Are we still being taught object-oriented programming for the young people in this room? I don't see any young people in the room. Yes. Yeah, you still get them? Good. That's great. And of course, functional programming, because that's more hip. But this is trivial. This is stuff that we learned a long time ago, and apparently we still don't do that. Encapsulating all your primitive types into first-class citizens. Encapsulate logic. Data hiding. Remember that from the past? Very simple. So that's the code part. We still have design and architecture left. It's a lot of content. I know I'm going pretty fast in this talk, but the point is that you don't have to remember everything. You just go to the slides, and hopefully you remember that next Monday. Organize your code by functionalities, capabilities. Start to restructure code that is now in technical folders. Structure them in a functional folder. Makes it much easier to understand what belongs together. That is part of your design. Restructuring the code base. If it happens to be something like an HTTP endpoint in .NET, you have controllers, you have views, you have view models. They're probably grouped in folders like that. Regroup them, put the things together that belong together. Makes it easier to understand how things are being used. Because when you're refactoring existing code bases, you want to understand how everything relates and where the coupling is and how you want to get rid of the coupling. Well, that's one way of doing it. Organize stuff by slice. Starting to think about what piece of code here is actually supposed to be used in different places. Does it actually align with that structure that you just built up? Isn't it actually going to be easier to just duplicate some code to remove coupling? And if you really want to keep that code because it looks complicated, move into a separate part of the code base so it's very obvious that this is a piece of code that's reusable. But the vice versa also applies. There might be code in some kind of common or infrastructure or helpers project that is only used in one place. Then remove it back to the caller that's actually there, or even remove the implementation and make it an inline implementation. Anything that is not generic, make it specific, because again, the less generic code you have, it will also easier to understand all the dependencies again. And by the time that you're doing this, you probably also already have a pretty decent mental model of that legacy code base. Or you already have it because it's your code base. Yeah, it used to happen. Here you see a couple of things. You're basically duplicating stuff, like duplicated service in different in this case, I'm using a vertical slice architecture, helper methods, extension methods. They're notorious in the .NET space. They're everywhere. Just copy-paste them in the place that you need them. Don't introduce extension methods because you think they might be reusable. And if they exist and they're not being reused, move them back to the caller so that it is very close to each other. Because you cannot, your brain, at least my brain, cannot process all that complexity. You want to reduce, if you look at a piece of code, you want to be able to understand that code without having to understand everything around that. I mean, this is all about what object-oriented programming is. If you're starting to create your tests, your unit tests, and I covered this yesterday as well, try to identify those boundaries that you did while refactoring. Start to create unit tests for these pieces of blocks. Because that's the ultimate goal. You started with characteristics tests, but you want to get rid of them. You want to actually gradually introduce automated testing at a much more smaller scale so that you reach the point that you can rip out the characteristics test and still have this high coverage that you need to be able to deliver a new version, I hope. So yeah, basically like this. Click, yeah. This is an example of where I actually put code in a functional structure. I still have an infrastructure thing here, a folder, which contains complicated, reusable piece of code. I have a folder called distributed logging, which is what it is. It provides a distributed logging mechanism. It has a class called cluster-wide log provider, which is probably the implementation, and one interface. I provide cluster-wide log. I like these role-based interfaces, which also aligns with the interface segregation principle. But what's interesting is I have a folder called internals, which contains code that on first sight might actually look like it's generic. And probably it may be generic, but I didn't intend it to be generic. So I make it very explicit, almost dogmatically explicit, that that code is supposed to be internal. It's an implementation detail of this whole folder. Why is that useful? Because if somebody actually accidentally used the SQL Server error enumeration in a different place in the code base, in .NET you actually see using infrastructure.distributedlogging.internals. And that should trigger, hopefully, a code review comment like, hey, why are you actually including something that is internal detail of another piece of code here? It's a very simple trick. And you can probably even use something like ndepend. I've never tried that. But that's a way of doing it. Skip all the details. Same with the JSON folders. Yeah, if you start to treat it like as separate units or separate boundaries in your system, again, will make things difficult. So you're basically reshuffling that existing code base to align more with this functional separation. Design patterns, same thing. Design patterns is a way to structure your code so you can give names to it, and people recognize that. I think I read somewhere that the authors, which are on this picture, 10 years after they wrote that book, they actually said we should have called it refactoring towards design patterns, because there were too many people, and I'm pretty sure some of you in this group have been a victim to that. They used patterns as a goal because it was cool. You know, I've actually implemented the visitor pattern. Has anybody actually implemented the visitor pattern in their life and still think it was a good idea? Oh, okay. You have built something very powerful, very complicated. But if I tell you that I'm using a strategy pattern, you see like blah, blah, blah strategy, I think most cases you pretty quickly know what it's supposed to do and what kind of structure to expect. The same with instance, singleton pattern, adapters, factories. I don't even have to explain to you what it means. It's such a common term. It is actually a design pattern, and that's what that book actually accomplished. They gave us a vocabulary to express complicated technical solutions, and that's the value of that. So refactoring towards design pattern. I did that with Fluent Assertion. Over the years, I started to refactor things, and then I thought, like, there's a pattern, and if I structure it a little bit according to the pattern, use the naming convention, the next person will know exactly what to expect. Maybe adopt an architecture style that kind of adopts embraces the idea of inversing the dependencies. This is an example from a slide I also had yesterday. I have the order processing module, and the order processing module takes a dependency on an interface called iStoreOrder, which is a very generic interface. Literally, it's a C# generic interface, so you can put anything in there. Any type that, I don't know, you use in Hibernate or anti-framework. The problem is, this is generic code. And generic code tends to be generic, more complicated, becomes also more generic over time because we like to put more logic in there because of dry and everything. When you apply the dependency inversion principle, you're basically saying, like, you know what? The order processing module needs certain capabilities from the rest of the system. And instead of relying on some kind of low-level abstraction, it basically defines its own contract, its own interface of what it needs. And now, this repository implementation that uses an Hibernate or anti-framework or something like that implements that contract. And that's a really significant change in the perspective. It really enables things to work in a different way. I think DIP, the dependency inversion principle, is one of the most important principles Solid. And I think Solid is still very valuable. I know there's people that have been complaining about it or trying to debunk it. It's still very useful. It's just something you have to, just like any principle, don't apply it dogmatically. Try to understand where it's useful or not. Another thing which I do is to actually think about dependencies on the package level. For example, I have a main package. That's generally how I build things. And then in that package, I have like small building blocks which serve their purpose, are very simple to understand, and can be combined in a very smart way, but you don't have to, and you need to understand the different building blocks. So what I don't like is frameworks. I don't want to deliver a framework where you inherit from a base class, suddenly all kinds of magic happens. I want the developers to understand that magic by training them what the magic actually consists of. Because magic is magic because you don't understand it and something happens that you cannot explain. But if you understand what happens, it's not magic anymore, right? If you take your mobile phone back into the, I don't know, Middle Ages, people will think you're a wizard or witch or something like that. So the point is to actually break down that complexity into small chunks, explain how every piece of every building block is supposed to use, but also explain how they can be combined to be more powerful. Only then you provide something like, I would call them convenience blocks, things that combine them in a more common solution, but you need to understand the details. That's principle one, and there's names for that. The second principle is I try not to use inheritance anymore. I try to use composition instead of inheritance. Why? Not because object or inheritance is inherently bad, it's just that people tend to misuse it. And by applying the composition over inheritance concept, you're actually trying to decouple things a little bit more. The next thing is that you should only depend on packages that are more stable or more abstract. Because what's the biggest problem with all this dependency management, both in .NET with NuGet, with NPM and Yarn and all this stuff, is the dependency hell, the ripple effect. You update one thing and suddenly you and before you know it, you introduce a vulnerability because you forgot to enable vulnerability scanning. Because we're all using vulnerability scanning, right? A license scanning of all our open source software. No, we don't. So this is a simple principle. Only depend on more abstract packages or more stable packages. If you do that, that's the first thing to prevent rippling. The other thing I do is, if that package also supports some kind of optional capability, by having a dependency on another package. For example, on Hibernate can work with different database providers. It's all baked in, but you don't actually need a dependency on that. In this case, if I actually have that, I would have a package in between, which depends on the optional dependency and on the main package, which decouples the other one again. Again, prevents ripple effect. Also, anything that is not always used together with this, what's in this package, should be in its own package. Another effect. If you have some kind of component and you offer like a built-in test implementation, you do not want to ship the main package just because you fixed the bug in the test implementation. That doesn't make sense. You can, but that means that every time you introduce a fix or a capability, you also have to release a new version of the main one. And releasing new versions means you have to think about versioning, semantic versioning, backwards compatibility. By doing this, you end up with potentially more packages than you may like. It feels a bit unnatural, but it really allows you to control the amount of dependency hell that you can add, that you have. And of course, no cyclic dependencies. Of course not. So those are, again, steps to improve the design, the code, the design, deployability. We've done all of that. That's the point where you start thinking about the architecture, which is always the last step. You basically do everything you've learned. You've built your mental model. You understand the code bases. You understand what that code base is supposed to do, what are the environmental constraints, all the things you hopefully have picked up. Now it's time to think, okay, is the architecture that it currently uses the right one or not? Maybe it is using the right architecture. I actually worked with a team, and they were struggling with the unit testing scope and everything, and I actually discovered by understanding the dependencies, look at the code and trying to draw pictures by myself, that they were using an onion architecture. But nobody in the team had a clue they were doing that. Because it wasn't obvious from the code base. There was no screaming architecture. There were no visual representations. They didn't know. Well, it was actually a pretty nice architecture style for that. And the only thing I had to do is to rename some projects, rename folders to make that a bit more obvious for them. And then suddenly also, figuring out what's the scope of a test, what should be tested together, and what should be tested separately became almost a no-brainer. But if it isn't very obvious, or there is not an actual specific architecture, I would just define something. And I'm again using this picture because I was too lazy to create a new picture. But this is like, I basically come up with something. I literally create a diagram, something like that. I put it somewhere that people can see it, maybe in a repo, Confluence, SharePoint. Well, then you won't be able to find it back, but some other place. To help people also understand where are we moving this code base to. You know, and maybe you can use an onion architecture because it deals with the whole dependency inversion principle very nicely. Maybe in hexagonal, I can't even pronounce it correctly, but which is basically the same principle. It's just using different terminology like primary ports, secondary ports. But again, dependencies go inside, so it embraces the dependency inversion principle on the architectural level. Maybe clean architecture, which is Uncle Bob's own version of the onion architecture. Same principle. Could be. You don't have to, by the way. These architecture styles are supposed to solve certain problems. If you don't have those problems, don't introduce an architecture style like that. You know, I've had a lot of experience with event sourcing. It's a brilliant architecture styles if you have the problem that it's supposed to solve. But it should never be something you use because you like to use it or because it sounds cool. Well, some people do, and you know, you can actually get new employers doing that. But again, they have certain purpose. Understand that. Oh, that's actually the end already. That's cool. Just in time. So I missed I actually removed the recap. So essentially, I'm going through the whole cycle. You know, understanding the production environment, understanding the code, removing the dead code, what is it more? Improving the deployment pipeline, adding characteristics tests, you know, building the safety net, and then gradually refactoring the code base, deleting old code, deleting that code, gradually introducing unit tests. Then at some point, you know, looking at the design, trying to structure the code base in a more functional way, making sure that you apply dry correctly. So things which are supposed to be reusable, keep them as a reusable piece of code, which is separately covered by test, because that's easy. Everything else, you start to just duplicate code because it reduces coupling, because that's what we want. We want to reduce coupling. I realized that was a lot of information on Friday morning, on the third day of the conference, after 2 nights of maybe drinking a bit too much. I hope you enjoyed it. I expect there will be questions. You can reach me through these channels. I love looking at this stuff and give you insights and you know, this stuff. I also do free consultancy gigs for this kind of stuff. So reach out to me. I hope you enjoy the rest of the day. I'm happy to go back to the Netherlands. And thank you for your attention.